When dealing with solid ground wires within a non-metallic electrical box, it is crucial to understand that simply twisting the wires together does not provide an adequate or code-compliant electrical connection. A proper grounding connection is essential for electrical safety, protecting against potential shocks and ensuring the correct operation of overcurrent protection devices such as circuit breakers and fuses. The purpose of a grounding system is to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection device to quickly trip and energize the circuit. This minimizes the duration of a fault and reduces the risk of electrical shock or fire. A poorly made or inadequate ground connection can impede this process, increasing the risk of electrical hazards. Solid ground wires, typically made of copper, require a secure and reliable mechanical connection to ensure continuous electrical conductivity. Twisting the wires together might seem like a simple solution, but it is prone to loosening over time due to vibration, corrosion, or thermal expansion and contraction. This can lead to a high-resistance connection, which defeats the purpose of the grounding system. Instead of relying solely on twisting, the National Electrical Code, or NEC, mandates the use of approved methods for connecting ground wires. These methods are designed to provide a permanent and low-resistance connection that will withstand the stresses of normal use. Firstly, one common and widely accepted method is to use a listed grounding connector, often referred to as a wire connector or wire nut, that is specifically designed for grounding applications. These connectors are typically green in color to easily identify them as grounding connectors. They are designed to create a secure mechanical connection between the wires, as well as provide a low-resistance electrical path. To properly use a grounding connector, strip the insulation from the ends of the ground wires to expose a sufficient length of bare conductor. The length of the stripped insulation is dependent on the connector and the instructions provided by the manufacturer. Insert the bare conductors into the grounding connector, ensuring that all the wires are fully engaged with the connector's internal mechanism. Then twist the connector until it is firmly tightened onto the wires, following the manufacturer's instructions for the appropriate torque or number of turns. Secondly, another approved method involves using a grounding screw and a pressure plate within the non-metallic box. Most non-metallic boxes are not designed to bond to the ground wires directly, hence the need for a different approach. If the non-metallic box is equipped with a grounding screw and pressure plate, strip the insulation from the ground wires and loop them around the grounding screw. Ensure that the wires are in direct contact with the pressure plate. Tighten the grounding screw securely to clamp the wires between the screw head and the pressure plate, creating a reliable electrical connection. It is important to note that the grounding screw should be made of a corrosion-resistant material such as stainless steel or brass to prevent deterioration over time. Thirdly, a similar method involves using a grounding clip. The grounding clip is designed to snap onto the edge of the non-metallic box, providing a grounding point for the ground wires. Strip the insulation from the ground wires and insert them into the grounding clip, ensuring that they are securely held in place. The grounding clip provides a mechanical connection to the box. However, because the box itself is non-metallic, the grounding clip does not bond to the box, instead bonding to the ground wires themselves. It is important to note that the NEC provides specific requirements for the size and type of grounding conductors, as well as the methods for connecting them. These requirements are outlined in Article 250 of the NEC, which covers grounding and bonding. The size of the grounding conductor is typically determined by the size of the circuit conductors, as specified in NEC Table 250.122. The grounding conductor must be large enough to safely carry a maximum available fault current without overheating or causing a voltage drop that could impair the operation of the overcurrent protection device. Furthermore, the NEC requires that all grounding connections be accessible for inspection and testing. This means that the connection should not be buried or concealed in a way that would prevent them from being easily examined. Accessible grounding connections allow electricians to verify the integrity of the grounding system and ensure that it is functioning properly. In addition to the NEC requirements, local electrical codes may also have specific regulations regarding grounding practices. It is essential to consult with the local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes and standards. When working with electrical wiring, it is always important to prioritize safety. Before making any electrical connections, always turn off the power to the circuit at the circuit breaker or fuse box. Use a voltage tester to verify that the circuit is de-energized before proceeding. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, to protect yourself from electrical hazards. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the work. A licensed electrician has the training and experience necessary to ensure that the electrical system is installed correctly and safely. In summary, twisting solid ground wires together in a non-metallic box is not an acceptable method for making a grounding connection. The NEC requires the use of approved methods such as grounding connectors, grounding screws and pressure plates, or grounding clips to ensure a secure and reliable electrical connection. Always follow the manufacturer's instructions and applicable codes and standards when making grounding connections. Prioritize safety and consult with a qualified electrician if you have any doubts or concerns. Remember, a properly installed and maintained grounding system is essential for electrical safety and the reliable operation of electrical equipment. Firstly, use listed grounding connectors. Secondly, use grounding screws with pressure plates if the box is suitable. Thirdly, use grounding clips where appropriate and permitted. Always consult the latest edition of the National Electrical Code, specifically Article 250, and local electrical codes for specific requirements and guidance on grounding and bonding practices. Ensure that all grounding connections are accessible for inspection and testing. If you are not qualified or comfortable working with electrical wiring, hire a licensed electrician. The consequences of improper grounding can be severe, including electrical shock, fire, and equipment damage. Therefore, it is crucial to take grounding seriously and adhere to the highest standards of safety and workmanship. Never compromise on safety when it comes to electrical work. The NEC outlines specific requirements for grounding electrode conductors, which connect the grounding system to the earth. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. The grounding electrode conductor must be made of copper, aluminum, or copper-clad aluminum and must be protected from physical damage. Common grounding electrodes include metal underground water pipes, ground rings, and ground rods. The NEC specifies the minimum length and diameter of ground rods as well as the requirements for their installation. Ground rods must be driven into the earth to a depth of at least 8 feet and must be spaced at least 6 feet apart. When multiple grounding electrodes are used, they must be bonded together to form a common grounding system. Bonding is another important aspect of electrical safety. Bonding refers to the process of connecting all metallic parts of an electrical system together to create a low impedance path for fault current. This includes metal conduits, metal enclosures, metal equipment frames, and metal water pipes. Bonding ensures that all metallic parts are at the same electrical potential, minimizing the risk of electrical shock. The NEC requires that all bonding connections be made using approved methods such as bonding jumpers, bonding bushings, and bonding locknuts. The size of the bonding conductors is determined by the size of the circuit conductors, as specified in NEC Table 250.102. In addition to equipment grounding and bonding, the NEC also addresses the requirements for grounding sensitive electronic equipment. Sensitive electronic equipment, such as computers, servers, and medical devices, can be susceptible to damage from voltage surges and electrical noise. The NEC recommends the use of dedicated equipment grounds and isolated grounding systems to protect these types of equipment. A dedicated equipment ground is a separate grounding conductor that runs directly from the equipment to the grounding electrode system without being connected to other equipment grounds. An isolated grounding system is a system in which the equipment grounding conductors are isolated from the building's normal grounding system. This can help to reduce electrical noise and improve the performance of sensitive electronic equipment. The NEC also addresses the requirements for surge protection devices, or SPDs. SPDO devices that are designed to protect electrical equipment from voltage surges caused by lightning strikes, power line disturbances, and other transient events. SPD are typically installed at the service entrance or at the equipment itself. The NEC specifies the types of SPD that are permitted and the requirements for their installation. SPD must be properly grounded to function effectively. Proper grounding and bonding are essential for the safe and reliable operation of electrical systems. By following the NEC requirements and using approved methods, electricians can ensure that electrical systems are properly grounded and bonded, protecting people and equipment from electrical hazards. Remember to always prioritize safety and consult with a qualified electrician if you have any doubts or concerns.